Now, our new lesson is scientific notation. What does it mean, scientific notation? Suppose you have a large number, like you are computing the distance from here to another galaxy, or another Milky Way from another. So the distances are very, very long. So the number will be very, very long. So scientific notation is give you the abbreviation, how to write the large number in a simple way. Also, if you look to a very, very small number, microwaves, like the distances between electron and neutron, it's very small number. So also it will be 0.000 something, very small. So also abbreviation of how to write it in another way. Let me start in this thing first, please. If you have any number in the, suppose you have a number 5. And number 5, I want to ask you, do you know that if there is a decimal point in this 5 or not? Many students, they don't know, but I will tell you that there is a decimal point here. And the decimal point, we don't put it because we don't need it. But the location of the decimal point is always here. Okay? So whether it will be 5.0 or 5.1 or 5.2, so this is the decimal point. So any number, remember that the decimal point is on its right. Any numbers, if I have 263, so the decimal point is here, without putting it. I hope it's clear. Something else I have to tell you, that when you multiply any number by any number, you are increasing the number. So if you say 2 times 10, so the 2 will become 20, which is more than 2. So any multiplication gives you increasing the number. So when you increase a number, if you have a 2.1, so times 100, so the 2.1 is how you move the decimal point 1 time, 2 times. Why? Because I have 2 zeros, 2 tens, 10 times 10, so 2 digits. So I move the point 1, 2, and fill here 0. So now the number is 210. Instead of 2.1, it will become 210. So remember, when you multiply, you are increasing the number, so the decimal point will go from to right side. And vice versa, if you have a number and you want to divide it by 10, suppose you have 2.1 and you divide it by 10, so I say go backward, put the point here, so it will be 0.21, which means 0.21. And this number is less than 2.1 automatically. So when we divide, we move the decimal to the left side. Why? Because you are decreasing the number. Now let me give you some examples about scientific notation. Now, I have a very large number, which is 201 million. I want to make it in a way that we can read it the same amount, if nothing changes, but in smaller size. So, let me remind you, I told you before, if you have 5, the point is here. So you have to put always the point after the ones digit here, okay? So I have to move a point here to be here, not before 2 or after 0. So the point must be always here. So normally, where did I say the point? If you have a number, normally it is outside. So look how many digits I'm moving. 1, 2, 3, 4, 5, 6, 7, 8, and I put the point here. So I will write 2, whatever I have here numbers, I put it down, 0.01 times 10 to power 1, 2, 3, 4, 5, 6, 7, 8, 10 to power 8. That's the scientific notation of this number. You want another example? Let's go for this one. Let's say the 3, 1, 0, 0, 0. Okay? It's easy. I want the point where I said here. So I take it 1, 2, 3, 4, 5. I put it here. So I read 3.1 now times 10 to power how many times? 1, 2, 3, 4, 5 digits? So 5. So that will be, remember that I have to put the decimal point which is next to the ones digit. Let's do some smaller number, okay? Okay, now, if you have a smaller number, very small number, 0.00000051. Remember, when I do, I have to put the point always in this, only one number I want it, so I'll put it here. So I'm moving now, increasing the number, so I said 1, 2, 3, 4, 5, 6. So what do I write now? 5.1 times 10 to power, I move it 6 digits, but negative way, because it is a smaller number. So once this indicates negative power, it means the number is very small. So if this, we call it standard form. So if I change it to scientific notation form, like what we did before, if I have here 3,100, so how many digits I have? I have here 1, 2, 3, so I write 3.1 times 10 to power 3. But if I have 0.0031, so I have to write 1, 2, 3, so 3.1 times 10 to power negative 3. So this is standard form, I change it to scientific notation, and this is also standard form, small number, I change it to scientific notation. Thank you very much. Now, if I want to change the scientific notation to standard form, okay? So if I have it in the form of scientific notation, how can I make it in standard form? It's very easy. Put 6 and 3 and 2. Now, I have to move the point, because it's multiplying by positive integer, I have to move it to the right. How many times? 5 digits. So I'll write here from 1, 2, 3, 4, 5. And each gap here, I put it as 0, 0, 0, and this will be the number. $632,000. If it is a small number negative, I have to go backward. So I put 4. Normally I said the point is always here outside. So I have to go back 7 times. From here to here, 1, 2, 3, 4, 5, 6, 7. So fill these zeros, put the point. Now this will be the answer. So 0.000004 without decimal point here, only decimal. I hope it's clear. The last concept I'll tell you after 1 minute. Now, if you have multiplying scientific notation, suppose you have a scientific notation here multiplied by another scientific notation. It's very easy. Just multiply the numbers. 5 times 3 will be 15, and the powers with each. So 10 minus 3 and positive 5, it will give you negative 2. That's the answer. It's very easy. Dividing, also if you have one dividing, scientific notation, dividing, same procedure. If you have 15 times 10 to power 2 over, let's say 3 times 10 to power 5. So automatically 15 divided by 3 is 5, and times 10 to power 2 negative minus 5 is negative 3. So I mean 10 to power 3. Negative 3. As simple as that. We divide this, so subtract the power, it will give you the same thing. It's clear, thank you.